event-driven architecture the cloud-native way. I'm going to tell you about both CloudEvents and xRegistry. So to get started, this is me, Manuel Ottlik. I'm a product owner at HDI Global, which is an industry insurance company based in Germany, Hanover to be specific. And I'm also writing articles about a bunch of cloud platform thingies in a German magazine publisher. My role in HDI is being the product owner of the global integration platform. That basically means bringing an API management, an event broker, and a service bus together. And today I want to focus on the last two, the service bus and the event broker, the asynchronous ones, because I'm going to talk about asynchronous communication, event-driven communication, and why that is harder than synchronous. And then I'm going to explain both CloudEvents and xRegistry to you, which aim to make this much simpler. So, why is asynchronous communication harder? We're now going to compare synchronous communication and asynchronous communication in patterns, products, and protocols. Those will be the three things. And we're starting with the patterns. And in synchronous communication, you're basically always doing request-reply. It's quite simple. So synchronous communication is easy. The asynchronous world is a little more complex. You got request asynchronous reply, which takes some time. You have message queuing, where you're basically firing and forgetting messages. You don't really care about the response. You have your event notifications that don't really have content in it other than, hey, something happened. And event-driven state transfer, which has exactly that context in it and that state in it. And then you also have event streaming and probably like a few more patterns that you can take a look at. So I think the slide makes it quite obvious there is more stuff in the asynchronous world. It's the same for protocols. You have REST over HTTP, you also have gRPC, GraphQL. Again, there will be more, but the majority of synchronous communication is done via HTTP and REST-ish interfaces. The asynchronous world has more protocols, and they have their own use cases. So you get AMQP, which is quite popular, and many brokers do support it, but you also have Kafka, which has risen in popularity, with Confluent rising in popularity. You still have MQTT, which is dominant in the IoT world. You have NUTS, which is a cloud-native event broker, and therefore quite popular in the cloud-native ecosystem. And you got WebSockets whenever you're dealing with a website. So once again, if you have a pie chart, there's like more equal shares in the asynchronous world, which makes it harder to deal with. And then you have the products. Now, what is important to say here is that in the synchronous world, an HTTP call usually is a direct call from one system to the other. So the products that I'm listing here are actually API management softwares that you don't have to use in order to do synchronous communication. Many use them, and I would recommend to use one, but they are less invasive in the way they deal with the actual data transfer, because the core of an API management is always an API gateway, which is just like a fancy HTTP proxy, where you can put some logic. You shouldn't put too much logic, in my opinion. So there will be Kong, Apigee, MuleSoft, Gravity, cloud-specific solutions for each hyperscaler. While in the asynchronous world, you do have your Kafka, you have your NUTS, RabbitMQ, and you have way, way more. The Apache Foundation alone has 3 or 4 on offer. And if you look at the hyperscalers, Azure alone has 3 different brokers you can choose from. It's the Azure Service Bus, Azure Event Grid, and Azure Event Hubs. So way more complexity there again. And that basically gives us a way more complex ecosystem to work in. And this is something that the guys from the serverless working group at CNCF, which is the Cloud Native Computing Foundation, have realized as well. First of all, you got many different brokers. Then you have many different protocols, and you probably use multiple ones each. HDI, for example, consists of multiple companies, and these companies have decided to use different event brokers with different protocols in their company. But we still have the need to transfer events from one company and one broker to the other one. So there is a lack of interoperability. Well, there's a formatting error there, but that shouldn't matter. So to increase that interoperability, I created this example on the right. The upper one and the lower one have the exact same payload. Same color, same content, same payload. But they use a different envelope. The first one using AMQP over Azure Service Bus, the second one using the Kafka protocol over Apache Kafka. And that's quite annoying because it's the exact same event. Why does it have two different envelopes? And CloudEvents is trying to fix that. It's putting a layer in there, which is, it's not trying to go for like a common event format, because attempts to do this have failed in the past, but it's about common event metadata and common headers. You can think of it like writing the same stuff on every envelope, no matter whether you're using packaging service A or packaging service B, or postal service A or B. So events can stay as they are if you're using the binary mode, which I'm going to show in a second, or you can have it included, which I'm going to show now. So Cloud Event always sounds quite fancy. This is basically what it is. It's like a few fields that got standardized and that everybody agreed to use. I'm going to start at the very top. The spec version is quite easy. That's the version of Cloud Events you're using. Currently, it's 1.0 out there for about 2 years, I think. Then the ID is the ID of your event. It's usually an UUID that gives you the possibility to see if you have processed an ID or an event already or not. The type is quite interesting because many conventions are possible here. You usually start with your reverse DNS notation. HDI Global as HDI.global as their domain. Therefore, we are using global.hdi. Then we're using the business object name and the event that has happened to it. So our partner got updated. That happened already. So it's in the past. Line 5 is the source. This is the system where the event has happened, where it is coming from. And here we are using an HTTP link to the API where you could fetch that object that the event happened in. And this is the line number 6, the subject. That is the ID. If you look in line 10, that is the ID of the partner that got updated. So if you now take source and subject and append those, you basically get a valid REST URL where you could look that object up, delete it, or update it, or do whatever to it. The time is quite easy. That's when the event occurred, not when the event was sent. And then the data content type is just the content type in which the data, which is 9 to 13, is in. I also have these borders around here, the blue one being the cloud event, the green one being the payload from the previous slide. So the payload is quite straightforward, didn't put too much stuff in there. That is just the partner that had some changes to it. That is the structured mode. Now, in the structured mode, you actually have to adapt how your event looks, because if you're using JSON, you don't have to use JSON. You can use whatever format you like, but then you're basically putting your data one layer lower in the data bracket. But if you just want to keep your format as it is, you can use the binary mode as well. This is an example for HTTP. There are a lot of protocol bindings for every common protocol, all the ones I listed before, where you can see from line 1 to 9 all the HTTP headers in there, where every cloud event header is prefixed with CE. So you got the exact same ones. I won't go over them again. And then you can see in line 8 and 9 the usual HTTP headers. So those will just be added to your protocol that you're using, in this case HTTP, and the actual content of the event, the payload, will stay untouched. So assuming you are doing eventing over HTTP, which might be uncommon, and you just have line 8 to 15 in here, you can just add these headers in there, and you will be able to send a cloud event, and it will be working with multiple brokers. Now, there are extensions to this. The HTTP headers, or the headers, the fields that I just showed you, are the base ones that you have to use. Not all of them are a must when using cloud events. But there might be use cases where you want more information on the envelope, basically. One famous one would be distributed tracing, which is something that is actually not that easy to do in the eventing world as of now. AMQP is working on an standard, but if you want to, you can just use it in cloud events, having the trace parent and trace state header added to it as well. And the second one being sequence, so you can have your 1, 2, 3, 4, 5 on your event, knowing in which order to process your messages if that's important to you. But you can also define your own. So if your company, for example, has a CI number for the service that it has come from, and it's for some reason important for you to have that in there, you can just define that. CloudEvents is part of the CNCF landscape. Those who do not know that, that is the Cloud Native Computing Foundation. Well, since we're on the Cloud Native track, I guess you do know. And if we are looking at streaming and messaging, which is just one small part of this very big landscape, we can see that CloudEvents is a CNCF graduated project, which means it's that mature that you can definitely build up on it. There is sandbox, incubating, and graduated. Those are the 3 levels. And CloudEvents is the first one making it to the graduated level in streaming and messaging. It is also featured by the ThoughtWorks Tech Radar, where inside the platforms quarter, it is listed as adopt. So basically, what I'm trying to say is get started. It will help quite a lot. This is the specification. One thing that is quite important to say: this is not a piece of software. This is just a specification, a standard that you can use as of now. You don't have to install it into your Kafka or whatever. What you do want to do is you modify your producers and consumers so they send and receive CloudEvents. And there are SDKs for that. You don't have to do that by yourself. You will find all the SDKs in that repo as well, or linked to the other repos. CloudEvents is therefore solving quite a lot of problems when it comes to interoperability, but there are still a few questions that are not answered. We might have our extension attributes on there, but we do not know where these events get produced or where you can consume them. And what happens if a schema of an event changes? You just told me you can use JSON patch, but you have to know where can I get that JSON patch from. So you somehow have to version your events. And you might want to validate them as well, either as a producer to make sure that what your system has produced is actually valid with the schema that you say you're sending, or if you're a consumer, check if the event you received is actually a valid event and therefore can be produced by your system. There's a different problem, because now that we have the extensions in there, how do I know which event actually uses which extension? Because you might have a very specific extension that makes sense in the insurance industry, but not somewhere else. So you're deciding to use it in that space, but not in the other. So we need to document how our events are looking. And there's a fourth problem: serializing, deserializing events not with Kafka, but with Avro. Needs you to have like a central place where you can have your Avro schema to serialize and deserialize an event. And that's where xRegistry comes into play. Now, first of all, things like these have been solved in the past by other registries. There are many schema registries out there at the moment. Confluent has their own one, Azure Event Hubs has one, Epicuri has one, Solace has one, but they all have their own standards. And if we're talking about one event traveling through multiple brokers meaning multiple registries, and therefore meaning to adapt to these individual registries and their features and their feature sets. So xRegistry is trying to put a standard on the schema registry. So you don't have to do that, because using a cloud event basically tries to make you independent of the broker and the protocol, but you can only do that if the registry is standardized as well. So what xRegistry is doing, first of all, it stands for extensible registry, and it is as powerful as the name says, because you can basically do anything with it. The core specification says that it manages metadata about resources, which is a very generic statement, because if you look at the broad model of a registry consists of groups of resources, and these resources can be versioned. That is like the very abstract model that we're going into. They do also, and we are lucky for that, have a more specific model about what they're trying to do, and that is for the event-driven architecture world. So it's divided into 3 things. The first one is events. What events do exist? Is it a cloud? It doesn't have to be a cloud event, by the way. You can, since it's extensible, you can do all sorts of stuff in there, all sorts of schemas. It has risen from that cloud event space, but it's capable to do much more. You can do your SOAP stuff in there, etc. So the events, what events do exist? Therefore, we have message definitions and their versions. So you can have a new version of your event, which might have a new extension in it. Then you have the schemas, that is basically targeting the payload that will be inside that message, because you might have the same schema in two different events, one being the XML version, the second one being a cloud event that is super modern, but the actual schema is the same. And then you have your endpoints as well, which gives you information about where events can be produced and consumed. And this can be done either as a file or as a REST API. The idea here is that you're able to start small by just having a simple JSON file inside your repository or next to your code that will list all the messages that can be published, all the events that can be published, all the schemas, and all the endpoints that will be in there. But as you evolve, and maybe if you're like a large corporation, you probably don't want your registry to be managed as a file. You can switch over to the implementation, and there will probably be implementations from vendors. In the serverless working group, there's people from Microsoft, there's people from Solus, there's people from SAP that are working on this model so that they can implement it in their products as well. And this HTTP model is basically as simple as or as abstract as you have seen it in the very beginning, where you have your groups, you have resources below your groups, and you have versions below your resources. And you can therefore get all the content and also have an HTTP reference in your cloud event to the schema that you're looking for. So I would dive deeper if I had a little more time, but you can find all the resources for xRegistry in the upper QR code, and the lower one actually is a much more detailed version of xRegistry of KubeCon 2024 this year in Paris. Highly recommend you watching it. If I'm going back, this content right there has been taken from there, from Klaus Deissner from SAP. And there are also code generators for producers and consumers, which is something that is quite important, which takes me to my key takeaways. First of all, asynchronous communication at the moment is more complex because there's less interoperability. There's more brokers, more patterns, more products. Second, using Cloud Event, it increases the independence of your protocols and brokers, and therefore you will have higher standardization and higher interoperability. And using xRegistry basically extends these benefits not only to the event itself, but also to the metadata that is around it when talking about event-driven architecture. Thank you very much.